Hey guys, welcome back to my channel. In this video, we'll be doing questions 3 and 4 from class 12 HSC Chapter 5 Vectors Exercise 5.1. This is from your Mathematics and Statistics Part 1. So basically, here you have a regular hexagon O, A, B, C, D, E. And what you do in this is that you have the position vectors of OA and OB, which is A vector and B vector. You are supposed to find the position vectors for C, D, and E with respect to O, which is your origin. Now, if you draw OC and AD, you get the center of the hexagon, which I have named here as X. If you realize OX and AB are parallel to each other, that means OX is equal to AB, correct? And AB here is basically your B vector minus of A vector, correct? Or OX here is equal to B vector minus of A vector. You turn this around, so here OA like this. So your AB vector is equal to OX vector, which is equal to B vector minus A vector. Now OC is just the double of OX. Therefore, OC vector is equal to 2 into B vector minus A vector, which makes it 2B vector minus 2A vector. Then you have to find for D. Now if you see, D is basically OC or OC vector plus CD vector. So since DC is equal to OA, it implies that CD is equal to minus OA, correct? So your OD vector is equal to OC vector plus CD vector, which is equal to OC vector minus OA vector. OC vector is what you have found here, so that's 2B vector minus 2A vector. And OA vector, which is this, is minus A vector. So you have 2B vector minus 2A minus A. That makes it a minus 3A vector. Next you have to find OE vector. OE vector is basically OD vector minus of DE vector. DE is parallel to AB, correct? Or ED is parallel to AB. So DE will be equal to minus BA. Or what you can say is that ED is equal to OX. So DE will be equal to XO or minus of OX. So you have ED is equal to OX. This implies that DE is equal to minus OX. So E vector is basically equal to OD vector plus DE vector, which makes it OD, it's 2B vector minus 3A vector, and your DE vector is basically minus OX, and your OX is equal to B minus A. So your XO will be equal to plus A vector minus B vector. So 2B vector minus B vector is B vector, and minus 3A vector plus A vector is minus 2A vector. So that's how you find your position vectors. For OC you have 2B minus 2A. OD, or the position vector of D, you have 2B minus 3A, and OE, the position vector of E, you have B minus 2A. Moving on to question number 4. So guys, here we have the fourth question. If A, B, C, D, E, F is a regular hexagon, show that AB plus AC plus AD plus AE plus AF is equal to 6OA. Okay, so now if you see, AB is equal to ED, and your BE is equal to FE, and CD is equal to AF. So let's note that down. AB is equal to ED, BC is equal to FE, and CD is equal to AF. Okay. Now, if you have to find AB plus AC, AB plus AC will basically be your it's going to come over here, and you'll have a vector going like this, correct? But then you also have a plus AD. So what we can do is we can make pairs that will all lead to one single vector. So if you see closely, you have AC here and AF here. If you bring AF here, that is, you shift it in place of CD, you have AC plus CD is equal to AD, correct? So you have AC plus CD, and don't forget to put the vector sign because they are vectors, is equal to AD vector. Another thing is that AE plus AB, AE plus ED, AE plus ED is equal to AD vector. But now CD is nowhere to be found, but you have AF. So you can write this as AD is equal to AC vector plus AF vector. And you can write AE plus, now ED is not there in your question. But if you see, ED is the same as your AB, correct? That's what we wrote here. So ED vector plus AE vector plus AB vector is equal to AD vector. So now if you see, you have AB plus AE, that is AD, and you have AC plus AF, that is AD. So if I write it, AB vector plus AC vector plus AD vector plus AE vector plus AF vector. We can write this. So AB plus AE, they combine to give you an AD vector. Then you have AC plus AF, which combine to give you an AD vector. And you already have an AD over here, correct? So that gives you 3AD vector. Now if you look closely, AD vector is basically the double of AO vector, because AO is in the center of the hexagon. That means it bisects AD. We know that AD vector is twice of AO vector. So what we can do is, let this be 1. Therefore, from 1, we get to know that AB vector plus AC vector plus AD vector plus AE vector plus AF vector is equal to thrice, and you found AD to be 2 times AO vector. That means it's 6 times AO vector, which you are asked to show in the question. So hence, you have verified what was given in the question. If they say hence verify, you say hence verified. If they ask you to prove, you write hence proved. And here, you have shown. Correct? So guys, that's it for the video. Don't forget to like, share and subscribe, and check out the other videos as well. And thanks for watching.